Hi, good afternoon. Can you hear me?
Good afternoon. Yes.
But yeah, good. I hope my screen is visible, right?
Yes, ma'am.
Yeah, so today is going to be the last live session for this term. Yeah, we can. I hope everybody is prepared with your exam, right? No answers. How is it going? How is the preparation going?
No comments, ma'am.
Yeah, good news.
Why? So,
Same here.
so how many courses are you taking? I suppose two, right?
Yeah, I'm taking only two. The rest of the people are taking four.
If it is four courses, then it may be hard. But if it is two courses, I think things can be managed, right? So things are manageable. Okay. Anyways, so as already told in the previous live sessions, 75% of the questions would be from Fourier transform and Laplace transform. The things that you should be very familiar with are the following, and also from the Fourier series. So I hope everybody is okay with writing the Fourier series representation for periodic signals. Okay, and the properties over here. So these are the things you should be very, very familiar with Fourier series when it comes to Fourier series. Okay, properties means like we have several properties, right? So when we add two signals, how does the Fourier coefficients vary? When we multiply, you know, all those things you should be very familiar with. Likewise, when it comes to the Fourier transform, so Fourier transform representation is there for both a periodic as well as periodic signals. So you should be, you know, uh, comfortable with writing the Fourier transform for any given signal. Likewise, for any given signal, there is also inverse Fourier transform. So any signal x of t in time domain can be represented as some other signal in the frequency domain, and likewise any signal in the frequency domain can be represented as a different signal in the time domain, and there is a Fourier transform associated with these two signals. One way is the Fourier transform and the other way is the inverse Fourier transform. Okay, so you should be comfortable with like what Fourier transform is, what inverse Fourier transform is. Properties are very, very important when it comes to Fourier transform. Only if you practice lot of questions on these properties, you will be comfortable with the Laplace transform properties. You won't forget them. So you have to brush through the properties of the Fourier transform. Like this, there is also Parseval's theorem over here. You should be comfortable with that theorem. Okay. So these are the things that you need to, like perfect when it comes to the Fourier transform. And moving to the Laplace transform, So why do we need Laplace transform in the first place? Fourier transform is not defined for every signal, every aperiodic signal. There are certain signals for which Fourier transform cannot be defined. However, like when you want to analyze the signal in the frequency domain, there are certain, so it is like this. So you have Fourier's, let's call this, okay. You have a whole signal space, all the signals. There are certain class of signals for which you can represent the Fourier series. So this is Fourier series, okay. And there is another class of signals for which you can represent the Fourier transform. Fourier series representation is contained because for every periodic signal we can also represent the Fourier transform. Should not say all periodic signals, but yeah, there are. I mean, for simplicity, for your understanding, now you can assume it to be like this. Okay. Likewise, there is a much more general space where there may not be a Fourier series representation, there may not be a Fourier transform representation, but the Laplace transform is defined. So this containment may not be strict. So I'm just using this picture for the illustration. So this is not the strict containment. There are signals for which, uh, but yeah, in general, you can assume it to be like this, like just for the illustration purpose. So Fourier transform is defined for much more broader signals, and Laplace transform is defined for even more broader signals. So that is what I meant by telling, by plotting this. Okay. So Laplace transform is also defined for the signals where the signal do not have the Fourier transform representation. So you so every signal x of t is also, if not every signal, the signal, uh, there are certain signals for which the Laplace transform is defined over that space. Every signal where the Laplace transform is defined, it has a Laplace transform which we represent by x of s. So Laplace transform is given by L, and there is also an inverse Laplace transform associated with it, which we give by L minus 1. And likewise, in the Fourier transform, even for the Laplace transform, we have several properties. You should be very much familiar with the properties. And there are very, very important theorems when it comes to the Laplace transform. One is the initial value theorem, and the other one is the final value theorem. Okay, so these are certain topics you should be very, very comfortable with before going to tomorrow's exam. And the rest of the 25% of the paper is concentrated around systems, mostly LTI systems, convolution, and signals. Okay, so yeah, so when it comes to NSEM, you should always prepare backwards. So you should start with the Laplace transform, Fourier transform, Fourier series, and then go to system signals. Okay, so this is, yeah, the way of preparing for in term exam. Okay, so this is just the gist of topics, that we will see in tomorrow's exam. But if you have any specific topics to be discussed or any specific questions, yeah, go ahead.
Ma'am,
Yes.
graded assignment 9 questions.
Question 7, right?
Yes, ma'am.
So you're supposed to find the Fourier transform. No, so you are given the Fourier transform where u of t is 1 by 3 plus j omega. Just a second, I'm trying to open the assignment. Okay, so this is what it is given, and you're supposed to, so provided that there exists a Fourier transform and inverse Fourier transform between these two signals implies Fourier transform of the signal is 1 by 3 plus j omega, and Fourier transform inverse Fourier transform of 1 by 3 plus j omega is given as e power minus 3t u of t. So given this representation, you are supposed to find the Fourier transform of the signal 1 by 3 plus jt. So what is the Fourier transform of 1 by 3 plus jt? Okay. So we have recollected in many live sessions. There is this duality property of the Fourier transform. What it says is, suppose if x of t is some signal with Fourier transform representation given by x of j omega, then 2 pi little x of minus j omega is the Fourier transform for the signal x of jt. In other words, so your signal e power minus 3t u of t has the Fourier transform representation 1 by 3 plus j omega. Now, this is your x of j omega. What is your x of jt? X of jt is 1 by 3 plus jt, right? This is your x of jt. This has the Fourier transform representation 2 pi times x of minus j omega. So this is your x of t, right? And what is x of minus j omega? E power 3j omega u of minus j omega. Correct? Uh, did I miss something over here? Okay, sorry. So if you call this whole thing as y of j omega, there shouldn't be this j factor coming in. Did I miss something over here?
Ma'am,
Yes.
so we just need to multiply by 2 pi and reverse the signal, right?
We just need to multiply what?
And reverse, and the independent variable will be omega. That's all.
Okay, so x of t has the Fourier transform representation x of j omega, right? Now we just need to reverse the signal. Uh, so which is x of minus omega and 2 pi, right?
No, reverse in the sense reverse the original signal, e power minus 3t into u of t.
Yeah, so e power minus 3t u of t has the Fourier transform 1 by 3 plus j omega. So 1 by 3 plus jt will have the Fourier transform representation 2 pi times e power 3 omega u of minus omega, right? That's what you're telling me, no?
Yeah, yes, yes. We are
Okay.
changing the t into omega because in this case omega the will be the
Mm,
independent.
yes, yes. So I think I have written something wrong over here. But okay. So okay, confusion. So don't get confused like me in tomorrow's exam. So if x of t has the Fourier transform representation x of j omega, as I think who helped me out, Subhash, right? So if this has the Fourier transform 1 by 3 plus j omega, then any signal 1 by 3 plus jt, to find the Fourier transform representation, just try to reverse the variable. So it is just 3 omega u of minus omega and then multiply by 2 pi. Okay. Duality property of Fourier transform. Is that okay, Satyam?
Yes, ma'am. And then my another doubt from graded assignment 10,
Mm.
question 6, 6 and 8,
Practice assignment or
graded
graded? Okay. Question 6 and 10.
6, 6 and 8.
So question 6 is telling you let the impulse response of an LTI system is given by del of t convolution with del of t by 2. Check if the system is invertible. So how do we check? Using the properties of Fourier transform, we know that h of j omega is 1 times 2, right? And sorry, this is 1 times 1 by 2, And what is the inverse of this? So h of j omega is 2. Since there exists an inverse exists
Ma'am,
Ma'am,
for, yeah,
this del of t by 2 is also 1, no?
del of t by 2 will not have 1 because like when you go through the Fourier transforms, minus infinity to infinity, del of t by 2, e power minus j omega t dt. Right? This is the Fourier transform representation, right?
ma'am, isn't it 2, ma'am?
Which one?
T by 2, del
This.
t by 2.
Yeah, let's see that. Maybe I have written it wrong, but this is the Fourier transform representation, right? For Fourier transform of del of t by 2 is, this is how we evaluate. And if you call this as some t prime, dt prime is equal to dt by 2. So dt is equal to 2 dt prime. So this is equivalent to this is equivalent to 2 times integral minus infinity to infinity del of t prime e power minus j omega. So t by 2 is t prime. So 2t prime times dt prime, right? Change of variables. And when I want to evaluate this, what is this? This is simply 2 times integral minus infinity to infinity del of t prime e power minus j omega 2 times 0 y del of t prime minus t naught times x of t prime is simply del of t prime minus t naught times x of t naught. Because of that reason, this is what it is. And this is simply 2 times integral minus infinity to infinity del of t prime dt prime, which is equal to 2. Implies the Fourier transform of this is 1 and the Fourier transform of this is 2. So the Fourier transform of the whole signal is the multiplication of the Fourier transforms of these two signals, which is equal to 2. And when you want to find the inverse of h of j omega, it is 1 over 2, which is defined for all values of omega, right? So this Fourier transform is defined for all values of the inverse of the Fourier transform is defined for all values of omega. Hence, the given signal is invertible. Okay, so if you remember in our earlier live sessions, somebody was asking like how to find if the given function is invertible or not. Then we were thinking, this issue might be resolved when we got the later lectures in the Fourier transform, and this is how it is. So you're supposed to find the h of j omega, the Fourier transform of the given signal, and try to find its inverse and see if the inverse is defined for all values of omega. If it is defined for all values of omega, then the given signal is invertible. Okay. Does that answer your question, Satyam?
Yes, ma'am.
Oh, and then there's also another question, 8. So what is 8 telling? So consider a periodic signal xp of t with fundamental period 2 pi. X of t, so this is a periodic signal with fundamental period 2 pi. And x of t is the signal that is defined in one particular period. You are given a1 is equal to 0.5. So since xp of t is a periodic signal, there is a Fourier series representation associated with it. And the Fourier series representation is as follows: k 2 pi omega naught t, jk omega naught t, where omega naught is 2 pi by t naught. Okay, and ak is calculated as 1 over t naught integral minus t naught by 2 to t naught by 2 x p of t, or you know, the given signal in within one period is denoted by x of t, e power minus jk omega naught t dt. Right? This is the Fourier transform and how you calculate the Fourier series coefficients. Now you are given a1 is equal to 0.5, and the Fourier transform of x of t is given by x of j omega. Then now you're supposed to find the value of x of j omega at omega equal to 1. So how do we do this? So if you write the Fourier transform xp of j omega, okay, and so xp of j omega will also be a periodic signal, and there is also a relationship between the Fourier coefficients of the given original signal and its Fourier transform, and the relationship is given as follows: ak is 1 over t naught, the fundamental period, times x of j k omega naught. So this is the relationship between the Fourier coefficients ak and the Fourier transform representation. The way you can get this relationship is go to your lecture slide on finding the Fourier transform for periodic signals. Okay, over there you can see there's a nice representation of writing this Fourier Fourier transform for this periodic signal. And when you try to relate these two expressions, at one point you can relate the values AKs with this expression. So this is something that you may be interested in knowing. So this would be your AK if the original signal has Fourier coefficients, Fourier series coefficients, AKs. Okay, and using this, so your A1 is given as 1 by the fundamental period is 2 pi x of j omega naught, and from this you have x of j omega naught. This is, sorry, I'm using omega naught over here.
Ma'am, it's omega naught only, no, ma'am?
Um,
It's a we divided 2 pi by time period.
Okay, yeah, true. Xj k by, yeah, true. Correct. Okay. So from this x of j omega naught is given as 2 pi a1. Okay. And yeah, your x of j times 2 pi by 2 pi is given as 2 pi a1. Why? Because t naught is 2 pi. And this implies that x of j times 1 is 2 pi times half, which is equal to pi. So x of j omega at omega equal to 1 is exactly this, and the value of this is equal to pi. Okay. So yeah, the crux of the problem is to understand this relationship. So how do you write this relationship? So try to go back to your lecture slide and see, for any periodic signal, there exists a Fourier series representation which is given as minus ak e power j k omega naught t. And you can always find xp of j omega for this signal in terms of ak's. Okay. And ak, like when you write the Fourier series representation of this periodic signal, ak would just be 1 over t x of j k omega naught. Is that okay, Satyam?
Yes, ma'am.
Yeah, I am here for another 20 minutes. Please, if you have any questions, please go ahead. If you don't have any questions, you can just leave the call and prepare for your exam.
Ma'am,
Yes.
practice assignment 10, question 10.
Mm.
So how to verify those statements? Ma'am?
Okay, so what happens when you, so this is where the differentiation property of the Fourier transform should be used. So suppose if you have any signal, if the Fourier transform of any signal x of t is given as x of j omega, the differentiation property of Fourier transform says dx of t by dt will have the Fourier transform as, I don't remember the exact transform, uh,
J omega x of j omega.
j omega x of j omega, right? Okay. So now, if you see, if this j can be written as uh, what is j? So j is uh, 0 plus j times 1, which is cos pi by 2 plus j sine pi by 2, correct?
Yeah, yes.
So this is the main idea behind the problem. So now you have to analyze each and every statement carefully. So you are given h of j omega is the Fourier transform representation for the signal h of t, and the magnitude response of the system be denoted by m of j omega. Likewise, the phase response is denoted by theta of j omega. Now, what happens to dh of t by dt? So so when we say magnitude, so h of j omega has a magnitude e power j theta of j omega, right? Or let's call this some j prime. Yeah. So that is what we mean by the magnitude and the phase. Now what happens to dh of t by dt? So this is j omega h of j omega. So this is j omega times m of j omega e power j prime theta of j omega. So yeah, so how can you write this?
Ma'am, so the magnitude response and phase response, what they
Sorry,
mean?
so this is sorry. So j is e power j pi by 2. Okay, so this you can write as I'll tell you. So this is e power j pi by 2 times omega. Okay, e power j prime theta of j omega. So I'm ideally using, so it is okay. So let me just clarify your question with telling like what the magnitude response and the phase response is. So for any signal, as we have done in our earlier sessions, there is this Euler's formula. So any signal x of t can always be written as any complex valued signal, right? Not any signal, any complex valued signal like a plus jb. This is a complex a of t plus j times b of t. This is a complex signal, right? So any complex valued signal will have magnitude m of t is equal to square root of a square of t plus b square of t, and theta of t, the phase, is nothing but tan inverse b of t by a of t. And this complex signal can be written as the magnitude times e power j theta of t. So there is always this equivalence relation, right? We
Yeah,
know
yes.
this. So any signal x of j omega is also a complex valued signal, right? The Fourier representation of a signal is a complex valued signal. So for this complex valued signal, there is associated with the magnitude along with the phase. And the associated magnitude is called the magnitude response, and the associated phase is called the phase response. Okay, is that okay?
Yeah, yes, ma'am.
So from here on, how do you proceed with this problem is any j can be written as e power j pi by 2, right, in the exponential form, because so j is nothing but cos pi by 2 plus j sine pi by 2. And we know this is e power j pi by 2. So this is one more thing that you have to understand. Now, what it is given in the problem is h of t has a Fourier transform representation h of j omega. So what happens to d by dt of h of t? So from our properties of the Fourier transform, it is j omega times h of j omega. J can be written as e power j pi by 2 omega times h of j omega, and h of j omega can be written as the magnitude, because it's a complex valued signal, j times theta of j omega, which is nothing but omega m of j omega times e power j theta of j omega plus pi by 2. So what happened when you differentiate the impulse response? As you can see, the phase response of the differentiated signal is added by an angle of pi by 2. Right? So
Yes.
hence statement 3 is correct. Definitely statement 1 is not correct because the magnitude is also affected by a factor of omega. So 1 is not correct. The magnitude response of dh of t by dt will be d, that you cannot say, information is not sufficient for statement 2 to be whole, and statement 4 definitely is not correct because there is a shift of pi by 2 in the phase.
Yeah, yes, ma'am.
In practice assignment 11 question 12.
Which one?
Practice assignment 11.
What is the question? I mean, which question?
Ma'am 2 and 8.
Okay. So x of t is an even function. What do we mean by the even function? So x of t can be written as x of t plus x of minus t by 2, correct?
Yes, ma'am.
Now, what happens to x of j omega? Or, x of j omega is given by integral minus infinity to infinity x of t e power minus j omega t dt. This is the Fourier transform. Now, what does this mean? Let's try to write this very carefully. So, this, let my t prime be minus t, okay? So, if my t prime is minus t, minus, minus x of t prime e power j omega t prime dt prime minus dt prime, which is also same as minus infinity to infinity x of t prime e power j omega t prime dt prime. Correct?
Yes, ma'am.
So this is again same as minus infinity to infinity x of minus t e power j omega t dt. Why? So x of t prime is same as x of minus t prime. So this is x of minus t. This is same as x of t. Alright. So I mean, what I'm trying to do is, this is exactly same as integral minus infinity to infinity x of minus t e power minus j omega t dt, right? Why? The given signal is an even signal and hence x of t and its x of minus t are equal. Okay, so x of j omega is same as, this, and again this. So as you can see, uh, x of j omega, these are certain things I guess professor had proved in class. I'm not really sure because that question was given by him. So these things require some proofs. X of minus t e power minus j omega t dt, call t prime as minus t. So this is minus infinity to infinity x of t prime e power j omega t prime minus dt prime. So this is simply integral minus infinity to infinity x of t prime e power j omega t prime dt. Correct? This. Yeah. So what this had showed is integral minus infinity to infinity x of t e power minus j omega t dt is equal to integral minus infinity to infinity x of t e power j omega t dt. This is true for an even signal, right? Yeah. Now,
Yes, ma'am.
when I try to do 2 times x of j omega, what happens to 2 times x of j omega? 2 times x of j omega is simply integral minus infinity to infinity x of t cos j omega t dt. Yeah. Why? So 2 times x of j omega is integral minus infinity to infinity x of t e power minus j omega t dt, uh, plus integral minus infinity to infinity x of t e power j omega t dt. So when I try to write this down, so this is integral minus infinity to infinity x of t e power minus j omega t plus e power j omega t dt. Correct? Why? So this is x of j omega. This is also x of j omega. And we have just seen that x of j omega can be written in these two forms. And when I just try to write in both forms, 2 times x of j omega is given by this nicer form. Yeah, for even signals. So this is same as integral minus infinity to infinity x of t 2 cos omega t dt, right? Implies x of j omega is integral minus infinity to infinity x of t cos omega t dt. So for an even signal, this is true. Is that okay?
Yes, ma'am.
So the crux lies in understanding that for an even signal, uh, these two are equal. And when you try to interchange the variables and write them out, what you get is these two are equal. So both are Fourier transforms for an even signal. So when you try to evaluate 2 times x of j omega, you write 1 x of j omega in one form and the other x of j omega in the other form. Both forms are equal. That is what we have seen for an even signal. When you just try to evaluate, this is what you get. And other question? What was the other question?
Question 8, ma'am.
Ma'am,
Yes.
in this question, can we answer this just by? Is it possible to answer this just by seeing the question?
Which one?
Because,
Second question.
yeah, yes, ma'am.
So there is a properties of Fourier transform for the even signal, right?
Yeah, yes.
What is the property? So if x of j omega is equal to x star of j omega, then it's an even signal. If the given Fourier transform and if its complex conjugate both are equal, then the given signal is an even signal, right?
Yes, ma'am.
And if you try to identify the x conjugate of j omega, that is also the same signal.
Yes, ma'am.
So hence this should be an even signal. But I mean, uh,
The
so I don't think you can answer this question by that, because the question is not asking you to see if x of j omega has this form, is the signal even. But
yeah.
instead, it's the other way around. If x of t is an even signal, then x of j omega will definitely have this form. So
Yes.
so you may have to write down and do the derivation that I have told you. But if it's the other way around, where you are given some form for x of j omega, and you looking at this form, if you're asked to identify if the given signal is even or odd, then by looking at the question itself you can do that. But I don't think in this case, uh, so because this is like a proper thing, so if x of t is an even signal, then definitely it will have this form. Okay, so you need to
Mm.
verify that by writing the steps. You cannot say that directly by looking at the problem. Okay,
Yeah, yes, ma'am.
but if you are given a specific closed form expression for x of j omega in terms of omega, then you can evaluate and see if x of j omega is equal to x star of j omega. If they are equal, then the given signal is even. Okay.
Yeah, yes, ma'am. Okay.
Okay, going to the eighth question. So you are given the Laplace transform of the signal x of t is equal to e power minus 2t u of t minus 2. So you're supposed to find the Laplace transform of the signal. Okay. Didn't we do this in one of our earlier live sessions? But anyways. Okay. So how do we go with this? So what is Laplace transform? X of s is given by integral minus infinity to infinity x of t e power minus st dt. and the given signal is integral minus infinity to infinity e power minus 2t u of t minus 2 e power minus st dt. What is u of t minus 2? The signal delayed by 2. So u of t minus 2 would be like this, right? Also, it's a right-sided signal. So this is a right-sided signal. So implies the ROC will be on the right side of the rightmost pole. That is something that you have to understand looking at the question. So the given signal is right-sided. So the ROC will be right to the rightmost pole, but we don't know what the pole is yet. We need to find what the poles are by finding the Laplace transform. So this is e power minus 2t e power minus st dt. This is integral 2 to infinity e power minus s plus 2t dt, which is 1 by minus s plus 2 e power minus s plus 2t to infinity, which is nothing but 1 by s plus 2 times e power minus 2 times s plus 2, right? So which is e power minus 4 times e power minus 2s by s plus 2. So this is the Laplace transform. Good. We found the Laplace transform. Now what are the poles? Poles are given by equating the denominator to 0. Poles are minus 2 is the pole. Now what did we see from the question? The ROC is right to the rightmost pole and the pole is 2. Okay. So let's plot the pole 0 plot. Here is where the pole is and the ROC is right to the rightmost pole. So this is sigma, this is j omega. So this is, in other words, real part of S, because S is equal to sigma plus j omega. Real part of S is sigma, right? So what should the ROC be? ROC should be right to the rightmost pole, hence the real part of S should be greater than S. Is that okay? So using the formula of the Laplace transform, we were able to find the Laplace transform of the given signal, and we need to know the ROC, region of convergence, and what we know is for any right-sided signal, the given signal is right-sided, hence the ROC should be right to the rightmost pole, and because of that reason the region of convergence is greater than minus 2. How did we identify minus 2? We found the Laplace transform and tried to find the pole, and from there we proceeded to find the region of convergence. Is that okay?
Yes, ma'am. Okay.
Ma'am,
Yes.
ma'am, could you scroll a little bit upwards? Yes, little down. Yes, yes. Ma'am, and for this question,
Mm,
actually we learned some formula in EEC course last time.
mm.
Uh, if we can, yeah, if we apply that, we can directly get the answer.
What is the formula?
E power at x of t equals.
I mean, if you're comfortable with that, you can go, but yeah, let's
Mm,
go with the standard way of proving
yeah,
it.
sure. Yes.
Any further questions?
Yes, ma'am. In graded section, same way. 11.
Uh, Graded assignment 11. Which question?
Question 1.
It's the same graded assignment, right?
Yes, ma'am.
Okay, so what does the question say? Uh, the Fourier transform of the given signal x of t is x of j omega. Then we are supposed to find if x of t plus t plus x of t minus t has the Fourier transform to x of j omega cos omega t. How do we find this? So let's try to evaluate the Fourier transform of this. We know that Fourier transform of x of t plus t is e power j omega t x of j omega, right? This is something that we know. Similarly, Fourier transform, how do we get this? I hope everybody is okay with this, right? Or do you
Yes,
have
ma'am.
questions with this? Okay. E power minus j omega t x of j omega. And Fourier transform is linear, right? Because of that reason, Fourier transform of x of t plus t plus x of t minus t, same as Fourier transform of x of t plus t plus Fourier transform x of t minus t. And what did we just saw? This is e power j omega t. Right? Right? So the given statement is true. Is that okay?
Yes, ma'am. And ma'am, in graded assignment also, question 1. Same way.
Which question?
1. Yes, ma'am.
Okay, find the inverse Fourier transform. So x of j omega is given as we know for some signals, standard signals like rectangular signal, the Fourier transform is given by tau sinc omega tau by 2 pi. What is sinc x? Sin pi x by pi x, right? Yeah.
Yes, ma'am.
So implies for the rectangular signal, you have the Fourier transform sin pi times omega tau by 2 pi by pi times I just tried to write it in sine forms. Okay. This is tau sine omega tau by 2 by omega tau by 2. So implies rectangular function t by tau has the Fourier transform 2 tau sine omega tau by 2 by omega tau. Now you're supposed to find the inverse Fourier transform of 2 by omega sine 3 omega. Okay. Now, yeah, tell me. So it's tau tau. So what should tau be in order for you to get this? Yeah, correct. So rectangular signal t by 6 has the Fourier transform representation. Is that okay? So the
Ma'am, explain it once again.
okay. So you're supposed to find the inverse Fourier transform of 2 by omega sine of 3 omega. There's some standard thing that we know for the rectangular signal t by tau. The Fourier transform is tau times sinc omega tau by 2 pi. This is something that we already know. Standard thing. I mean, the proof was given in your class, so you can try to do that. How do you prove that? You write this in terms of the unit step functions and then try to find the Fourier transform. So it's derived in your lecture video. So for the rectangular signal t by tau, the Fourier transform is given by tau sinc omega tau by 2 pi. So this is something that we already know. So yeah, from the given question, how do you even think that the x of t should be in rectangular form? If you see the given question, it is of the form sine 3 omega by omega. So the shape is in the form of a sinc function, right? So for any sinc function, uh, there's an equivalence relationship. So if the sinc function is there in the time domain, then equivalently in the frequency domain, you represent it by the rectangular function. Likewise, if rectangular function is in the time domain, frequency representation would be as in the sinc form. So from the given problem, from the given response function, Fourier response function, you can say definitely that in the time domain, the signal should be in the form of a rectangle. Okay, but what rectangle it is? So what are the values of the rectangle? For that, you need to know that for any rectangular function of the form t by tau, its Fourier transform representation is given by tau sinc of omega tau by 2 pi. And I just want to write the sinc function in terms of sine function so that it makes our life easier. So sinc of x can be written as sine pi x by pi x. So I'm just writing this sinc function in the form of sine. And when I write it in form of sine, like what I get to see is for any rectangular function rect of t by tau, its Fourier transform is 2 by omega sine omega tau by 2 sine omega tau by 2. So for any rectangular function rect t by tau, this is the Fourier transform, or this is the Fourier transform in terms of the sinc variables. Okay, so yeah, now you are supposed to find the inverse Fourier transform for this signal. So what is the inverse Fourier transform? Plug in tau equal to 6. So that should be your inverse Fourier transform, which is rectangular t by 6. Is that okay? Think about it.
Yes, ma'am. Okay.
Ma'am,
Yes.
if we are given rect t by 6 and are asked to find the Fourier transform,
Sorry, what? Can you repeat again?
No, if we are asked to find the Fourier transform of rect t by 6,
Mm.
how to find it easily, as we know the Fourier transform of rect t?
Okay. So any rectangular t by tau, any function rectangular t by tau will have the Fourier transform 2 by omega sine omega tau by 2. Okay. So suppose if you are asked to find the Fourier transform of rectangular 2 by 4, it is same as 2 by omega sine 2 omega. Okay.
Yes. So, ma'am, if we don't know this expression,
Mm,
but still we know that rect t gives us sinc function in Fourier transform, Fourier domain.
mm,
So it's rect t by 6 is nothing but the time scaling, right?
mm. Yes.
So just by knowing that, how can we get the answer?
Yeah, even that can be done. So you can use the properties of Fourier transform. So if x of t has the Fourier transform representation x of j omega, x of a t, what happens to that?
It's, the omegas will be divided by a.
Uh, I don't have the formula sheet in front of me. Okay, so
Yeah.
x of a t will have the Fourier transform uh, x of
The,
j omega by a times 1 by mod a, right?
yes.
Okay. And you know, if for rect t, you know the Fourier transform is something. It is 2 by omega sine omega by 2, right? Then for rectangular t by 4, it would be 1 by 1 by 4 times 2 by omega times sine of omega by 2 times 1 by 4. Yeah, which is there a factor of 1 by mod?
Yeah, yes, ma'am.
So then this would be what? So this is 4 times 2 by omega times sine of 2 omega. But yeah, this is just some calculation time is that I'm doing. But the whole idea is this. So if you know for any signal x of t, the Fourier transform is given by x of j omega, then for x of at, the Fourier transform would be given by this. So you can directly use the properties of Fourier transform to get to that.
Yes, ma'am.
Okay. Yeah, but there is some factor that I'm missing, but you figure out like, you know, there's some factor of 4. Uh, I don't know if it's over here through this method or if I'm missing in my previous method. Just check, verify that out, okay?
Yeah, yes, ma'am.
But the signal seems to be the same, but The amplification factor, I don't know like where I'm missing that. Maybe I'm missing it in the previous thing. Just verify that out once, okay?
Yes.
Alright.
Ma'am,
Yes.
did you already solve practice assignment 10 last question 11?
Let me open the question. Practice assignment 10, which question?
Last.
This I think last week somebody asked. Um, yeah, but I'm not a circuits person, but I'll try to give you some thought on this.
Just a quick
So,
solution is enough. Not in detail, very quick solutions.
okay, the quick solution is as follows. If you apply the Kirchhoff's law, KVL, or you know, whatever it is, so Kirchhoff's voltage law, right? So that just gives you 1 over 1 integral I of t dt plus y of t is equal to x of t. Okay.
Okay.
So this is from the KVL. Okay. Now what we know is we can just differentiate on the both sides and see I of t plus d by dt of y of t is equal to d by dt of x of t. I'm just differentiating on the both sides, and we know that the inverse of the differentiation uh, is the integration when you actually uh, see the limits. But in these kind of cases you can assume it to be like that, or you can also either you can do this, or you can also try to use the properties of the Fourier transform. If x of t has the Fourier transform representation x of j omega, then integral x of t dt. I don't have the formula sheet in front of me, but you know what this is, right? Using the properties of Fourier transform. So just apply that over here, and you'll get something in terms of I of j omega, y of j omega, and x of j omega, right? And yeah, and certain things are given. So, what is your
The exact answer is seems to be different, ma'am. Did
why is it
no,
different?
if others can help also, that's fine. Did they get the same answer?
So this is what I see as the answer. You can just verify like where your steps got broken. Okay. So I of t is again given as y of t. The current in the circuit is just y of t. And this is d by dt of y of t is equal to d by dt of x of t. From this, what you get is y of j omega times 1 plus j omega is equal to j omega times x of j omega. And you're supposed to find h of j omega. H of j omega is given by y of j omega by x of j omega. So h of j omega is j omega by 1 plus j omega. And yeah, you are supposed to find the inverse Fourier transform of this j omega by 1 plus j omega. And that would be 1 minus 1 by 1 plus j omega, inverse Fourier transform of this, right? And inverse Fourier transform of 1 is del of t minus 1 by 1 plus j omega. We know it is e power minus t of t. Yeah, the answer seems right to me.
Okay, ma'am.
Ma'am,
Yes.
I of t becomes y of t by 2, right? Or
Oh, yeah, that was my question.
Probably. I am not aware of this Kirchhoff's law things.
no,
Uh,
because of Ohm's law.
yeah, I could see that. The
Yeah,
current is
on
equal to.
It's just a half. So it will be half e power minus half t.
Okay, probably there is a factor of half missing over there. Okay, or the question should be replaced such that the resistor resistance is 1 ohm,
Okay.
right?
Yeah.
Okay. All right. Any other questions?
Yes, ma'am.
Yeah, tell me.
Ma'am, graded assignment 11, last question, 10.
Graded assignment 11. Okay. What happened to this? What happened to this problem? Could you tell me?
How to read data from the graph which is given?
So you're given the two poles, right? The two poles are at one at -1 plus J2, and the other pole is at -1 minus J2. You're given two poles. So on the pole 0 plot, but yeah, I don't agree with this question fully because the poles are supposed to be. Yeah, I don't kind of believe with this question. For now, please ignore this question. I don't believe with the solution. I need to verify this with the professor. Okay. For now, you can ignore this question. But if you're given a pole zero plot, the poles and zeros are represented on the real part of S axis. So over here, you represent poles and zeros. So suppose if your 0 is at A, your pole is at B, two poles are at B and C. Okay, this is j omega axis. Then your transfer function is given by S minus A divided by S minus B into S minus C. Okay. This is the way to calculate. But for this given question, yeah, I need to re-verify this question again. So for now, you please ignore this question. Okay.
Okay, ma'am.
Thank you.
And ma'am, could you explain question 2 also? Same assignment.
Question 2. It's the same, right? So hints are also given in the question. So what is there over there? Just have to use the frequency shifting property. You need to practice this. Okay. So it's just the application of previous thing. You just have to use the frequency shifting property. Nothing more to it. Yeah. And what does frequency shifting property say? If x of t has Fourier transform x of j omega, then x of t plus t e power j omega t x of j omega, or the other way is also true, e power j omega naught t j omega naught t x of t x of j omega minus omega naught. Okay, so this is the frequency shifting property. So in the previous question, we found something. Just apply frequency shifting property to this question. Is that okay?
Okay.
Yeah. Any other questions?
Ma'am,
Yeah.
the question which we discussed before, which question is it? Was that?
10th question in week 11.
Week 10 graded assignment.
Okay, week
Practice.
10. No, week 11, right? So this is week 11. Practice assignment 10th question. No, graded assignment week 11, 10th question. Okay.
Yeah, yes.
Yeah.
And ma'am, the
Yeah.
circuit problem which we discussed earlier.
Mm.
So what answer should we get if we try to attain the solution for the given circuit?
I think as she told, it should be minus t by 2 or something. There's a factor of 1 over 2 that will be coming up. But
Yes.
you can assume that the resistor's resistance is 1 ohm. Okay, for now.
Yeah, yes.
Any other questions?
Ma'am,
Thank you. Yes.
practice assignment 12, third question.
Mm, yeah. I think this is some problem worth solving. X of s is given as log e 1 by s plus 4, and you're supposed to find the inverse Laplace transform. Note that x of s is log e1. Yeah, and this is simply minus log e s plus 4. And when you try to find dx of s by ds, that would simply be 1 by s plus 4, right? We know why d by dx of log x 1 over x, or d by dx of log f of x is 1 by f of x times f prime of x. Okay, and we know the inverse Laplace transform of this signal is minus dx of t. This is inverse Laplace transform of this signal is minus e power minus 4t u of t. Yeah, and from here you can identify x of t is 1 over t e power minus 4t u of t. Is that okay?
Okay. So we need to differentiate. Is it?
Yeah, I mean, because
Mm,
otherwise it might be difficult.
yeah,
So,
we eliminate log.
mm, mm.
Okay.
Any other questions? Yeah, if there are no more questions, can we just end today's session?
Ma'am,
Yes,
like the fourth one also.
week 12. Okay. Practice assignment only, right?
Yeah, yes, ma'am.
Again, word solving. So x of t is given as t e power minus 3t plus 2 u of t minus 1. And you're supposed to find the Laplace transform of the signal. So how do you go with? Oh, I think this is something that we solved in our last live session, right? Yeah, exact same question we did. So are the solutions uploaded?
Not sure.
Yes, ma'am.
In the
Yes, ma'am.
oh,
Okay, if the solutions are uploaded, please go through it. This is
yes,
the exact same question we solved it in the last live session. Okay?
yeah, yes. Then 10th question.
Yeah, 10th is also something that we solved in the last live session.
Yeah, then okay.
Okay.
Yeah.
So you can just have a look. I asked with the team to upload the last live sessions. Okay. All right. Yeah. Week 12 doubts were uh, discussed in the last live session. Okay. All right. If there are no more
Yes.
questions, can we just end the session for today?
Okay, ma'am. Thank you, ma'am.
Yes, ma'am.
Thank you so much. Yeah. Please write your exam well. A very good luck from my side. Okay. Yeah.
Thanks a lot.
Let's keep in touch. Yeah. Bye.
Thank you, ma'am.
Thank you. Bye.
Thank you so much, ma'am.
Thank you. Thank you.